Hello everyone, welcome back to Diksha Vedantu Foundation channel, and today I am going to discuss the physics part of sample paper number 9. The paper link is shared in our WhatsApp channel, and if you have not subscribed to our WhatsApp channel, the link of the channel is given in the description. Also remember that if you are watching this video for the first time, don't forget to subscribe to our channel so that our subscription base increases, right? We are going to discuss the sample paper 9 of the part, and only the physics part. Chemistry and biology is already discussed by respective ma'ams. Now let's see what is the question composition looks like. So this is slightly odd question paper. Why? Because at least 6 1 marker question is coming from this paper. Then we have 2 marker question, 2 3 marker question. We have 1 5 marker and 1 4 marker as usual, and if you add them up, it is coming to 29. But generally we see only 25 marks coming for physics. Anyway, more questions better for us. We can practice it more, right? So let's see the question number 13. Consider the following statements in the context of human eye. The diameter of eyeball is about 2.3 centimeter. Iris is a dark muscular diaphragm that controls the size of the pupil. Most of the refraction for the light rays entering the eye occurs at the crystalline lens. While focusing the object at different distances, the distance between the crystalline lens and the retina is adjusted by ciliary muscles. The correct statements are, so we have to find which of the following statements are correct. So first let us see which is definitely we know are correct. So for example, while focusing the objects at different distances, the distance between the crystalline lens and the retina is adjusted by ciliary muscles. Okay, so distance is not adjusted by ciliary muscles. Ciliary muscles only control the aperture of the crystalline lens so that you can see clear objects. Okay, the distance between retina and the lens is not adjusted, the focal length is adjusted. So definitely this is a wrong statement. So whatever we can see containing D are incorrect. So C and D are incorrect. Let's see anything else that we can eliminate or not. Okay, suppose we do not know what is the diameter of eyeball, right? So how can we answer such questions? Iris is a dark muscular diaphragm that controls the size of the pupil. So this is a correct statement. So option B is a correct statement, which is a iris, our dark diaphragm that controls how much light we can receive from atmosphere. So that is the part that controls the size of the pupil. So this is the correct statement. Now let's see option C. Most of the refraction of the light rays entering the eye occurs at the crystalline lens. So most of the light that enters our eye, that gets refracted through our lens, right? So option part C is also correct statement. So now see which of the options have both B and C as correct. Okay, so if you see option B has A, B and C are correct. So B and C are correct, we already know, right? And A is also a correct statement. The diameter of eyeball is about 2.3 centimeter. In case you don't know, okay, you can check what else, what other points that you know, what else are correct directly. Okay, so for example, as I said, this option D is not correct. Option B and option C is definitely correct, and option A is also correct. So definitely A, B and C are correct statements, right? Now let's move on to the question number 14. The maximum resistance of a network of 5 identical resistors of 1/5 ohm each can be maximum resistance. So maximum resistance occurs only when they all are connected in series. In any other combination this is not possible. Okay, and minimum resistance is possible only when all of them are connected in parallel. In any other combination, the range will be between the maximum and minimum. Okay, maximum resistance means resistances are connected in series, minimum resistance means they are connected in parallel. Okay, if you add any other combination, say 2 series, 3 parallel, then it will be in between those two values. Okay, so here maximum of 1/5, so 1/5 ohm each. So how many resistances we have? 5 resistances. So we know that there is a shortcut. When all of them of same resistance and connected in series, their equivalent resistance is simply multiplied by their number, so it will be 1 ohm. 1 ohm will be the correct answer. Now let's move on to the next question. Study the IV graph for 3 resistors of resistances R1, R2 and R3 and select the correct statement. So here we have 3 resistances R1, R2 and R3. Here along this axis we have ampere current, along this axis we have volt. Okay, and we have to identify which one is greater, if they or they are equal or not. So what is the relationship between R1 and R2? So how to do that? Okay, for that we will take the help of our known formula, that is Ohm's law. Ohm's law states that V equals to IR, okay, or R equals to V by I. Okay, so R equals to V by I. Now if we can make I constant, okay, if we can make I constant, whoever has higher potential or higher voltage, okay, that will have higher resistance as well, because we can see that resistance is directly proportional to voltage if current is constant, right? If current is constant, then resistance is directly proportional to voltage for a given IV graph. This is only valid for IV graph analysis. This is not a general statement. Now how can I make current I constant? So for that, what we have to do, we have to draw a straight line parallel to volt axis. Okay, if I draw a straight line parallel to volt axis, you can see that this line represents a constant current I. Okay, that means at this point and this point, these 3 points have the same current. These 3 points have the same current. Now we have to identify which one has the highest voltage. So for example, R3, if you see R3 is definitely having a higher voltage. So this is V3. Okay, now if you see this will be V2 and this will be V1. Now as you can see, definitely this is a higher value because it is further down the x-axis, right? This is a lower value. V1 is the lowest, V2 is in between V1 and V3. So V3 is the highest value. That means R3 is the highest resistance and R1 is the lowest resistance. R2 is in between as expected, right? So which one we will answer? R3 greater than R2 greater than R1. So this is the correct statement. So R3 definitely greater than other 2 resistances. So R3 is greater than R2 greater than R1. This is how you can answer such question. This is a tricky question, not super easy to answer, but if you know how to answer it, you can answer. Now, next question. Strength of magnetic field produced by current carrying solenoid does not depend upon number of turns in the solenoid, direction of current flowing through it, okay, radius of the solenoid, material of the core of the solenoid. Now they have said only the strength of magnetic field. So how strong it is? So strength is independent of the direction of current. Okay, the polarity will change. That means north pole and south pole direction will change, but it will not depend on the direction on which it will be stronger. Still, if you are sending same amount of current, it will be same strong, only the magnetic field polarity will change. So strength does not depend on the direction of current, but it depends on number of turns. It depends on radius of the solenoid. It depends on the material of the core of the solenoid. So if you have learned how to increase the strength of electromagnet, these are the main points that you have to mention. Number of turns increase, okay, radius of the solenoid must be decreased, and material of the core, we should paste something like soft iron in the core to increase its strength, right? These are the main points. Now question number 19, this is an assertion and reason based question. So what is assertion? Says myopic eye cannot see distant object distinctly. So myopic eye, people like me wearing specs, I am suffering from myopia. I cannot see distant object clearly. So correct statement is, this is the correct statement. Now what is the reason they have given? For the correction of myopia, converging lenses of appropriate power are prescribed by eye surgeons. Okay, first of all, myopia is corrected using diverging lenses or concave lenses. Okay, converging or convex lens are used for hypermetropia. So this is definitely not correct. Reason is not correct. Secondly, in case the same question was asked by saying diverging lens or concave lens, then also this is not the reason. Reason would be correct in that case, but this is not the correct reason. The reason is that either there are two reasons, we know that, right? For myopic eye, there first of all the ciliary muscles cannot converge the rays into the retina, or you have an elongated retina, you have a shortened retina, the distance between the lens and the retina decreased, okay, so that shortened eyeball basically, so that the light rays are not falling on the retina, it is falling behind the retina, right? So that is how my mistake, the retina is the eyeball is elongated. If eyeball is elongated, then the rays are falling even before reaching the retina, that is myopia. If it is shortened, then it is hypermetropia. Okay, so retina, according to the statement, obviously the reason, there are two reasons: eyeball is elongated, or your eye lenses are not able to relax so that you can converge distant rays easily. So these are the two reasons. Other than that, any other reasons given, okay, even if they are correct factually, they are not the correct reason. Okay, so only A is true, R is false. Okay, so only A is true, R is false, so correct answer is option C. Now next question, assertion: the deflection of a compass needle placed near a current carrying wire decreases when the magnitude of an electric current in the wire is increased. So magnitude of electric current increased, then deflection is decreasing. That means the magnetic field is getting weaker. Is it the case? Is it the case? If you increase the current, the magnetic field should get stronger. So the deflection should increase instead of decreasing. So definitely assertion is not correct. Let's see the reason. Strength of the magnetic field at a point due to a current carrying conductor increases on increasing the current in the conductor. So as you can see, these two statements are self-contradicting. The reason statement is definitely correct. Okay, if this is not correct, then this is definitely correct. Similarly, if they give you opposite to that also, then you can figure out, okay, both of them are contradicting, that means one of them has to be correct. Which one? You have to figure it out. In this case, current, if you increase the current, magnetic field increases, so definitely in this case reason is correct, but assertion is false. So A is false, but R is true. Option D is correct. Now let's see the 2 marker section. State 2 laws of refraction of light. Define the term absolute refractive index of a medium. A ray of light enters from vacuum to glass of absolute refractive index 1.5. Find the speed of light in the glass. The speed of light in vacuum is 3 into 10 to the power of 8 meter per second. Let's see the answer. Okay, so first, the incident ray, the refracted ray, and the normal on the surface at the point of incidence lie in the same plane. Okay, the ratio of the sine of the angle of incidence I to the sine of the angle of refraction R is constant for a given pair of media, that is n equals to sine I by sine R. This is the refractive index. Now absolute refractive index n of a medium is the ratio of speed of light in vacuum, that is C, to the speed of light in medium. So speed of light in vacuum divided by speed of light in the medium. So as you can see that refractive index for vacuum is C, and refractive index speed of light in vacuum is C, and speed of light in any other medium is V. So this is the ratio. Okay, now given now the next question, they have given you n, they have given you c, you have to calculate the speed. Simple formula, you just say that v is equal to c by n, so it will be 3 into 10 to the power 8 divided by 1.5. now 1.5 and 3 can be cancelled with the 2 factor, so basically speed of light in glass is 2 into 10 to the power of 8 meter per second. Simple question. Now let's move on to the next question. Use Ohm's law to determine the potential difference across this 3 ohm resistance. Okay, so we have to use Ohm's law to calculate the potential difference across the 3 ohm resistance, this one. Okay, in the circuit shown below when the key is closed. So key is closed, so we have to find the current. So current, how to do that? First we have to apply the Ohm's law. First, these 3 resistances, you can see that they are connected one after another. One after another means total resistance is definitely is series combination. So 2 plus 3 plus 1, that is 6 ohm is the equivalent resistance. Now if 6 ohm is the equivalent resistance, what is the current? Current is basically potential difference, that is voltage supplied divided by the total resistance, that is 1/3 ampere. 1/3 ampere is the current flowing in the circuit. Now if 1/3 ampere is the current flowing in the circuit, then this much current will flow through all the connected resistors. So 1/3 current will pass through this, 1/3 current will pass through this, 1/3 current will pass through this as well. Now what is the voltage drop across this resistance? Voltage drop, there was a question once, I think, power in a circuit. So power can also be calculated, voltage drop can also be calculated. To calculate voltage drop, it is simple. Okay, we just need to do I into R, that is I is 1/3, that is same for all the components. R is 3 ohm, so it will be 1 volt. So 1 volt is the voltage drop across this. Now if they ask you power is equal to, formula is, power is basically I square R, same formula. I is 1/3 and R is 3, you just put it, you will get 1/3 watt. Okay, 1/3 watt would be the answer in case of power. Now let's see the answer given. Okay, okay, they have done something wrong. The voltage they have considered 6 volt, but they have in the diagram it is given as 2 volt. Okay, so even though the process is correct, this will be this is wrong. Okay, this will be 2 volt by 6 volt. This will be 2 volt by 6 volt, so it will be 1/3. So 1/3, it will be 1 volt, not 3 volt. So the standard answer given for this question paper is incorrect. Okay, it will be 1 volt. Now let's see the 3 marker questions. Define the term power of accommodation of human eye. Write the name of the part of the eye which plays a major role in the presence of accommodation, and explain what happens when the human eye focuses on nearby objects and distant objects. Very common question. I have discussed this in my regular class as well. Let's see. Power of accommodation, I think this diagram is somewhat incorrect. Okay, this diagram may be for the next question. Okay, so this diagram is, ignore this diagram for now. Power of accommodation is the ability of the human eye to adjust the focal length of its lens to focus an object at varying distances, and the part which is responsible for controlling that is ciliary muscles. Okay, how do we see nearby objects? Ciliary muscles contract, making the lens thicker and increasing its refracting power. That is how we see nearby objects clearly. Okay, distant objects, ciliary muscles relax, making the lens thinner and reducing its refracting power. So that is how we see distant objects. Okay, this is the standard answer. 3 more questions, 1 1 1. I think this is 0.5, this is 0.5, 1 and 1. This is how the 3 marks is distributed. Now let's see the question. Draw a diagram to show the pattern of magnetic field lines on a horizontal sheet of paper due to a straight conductor passing through the center and carrying current vertically upwards. Mark on it the direction of current in the conductor, the corresponding magnetic field lines. State the right hand thumb rule and check where the direction marked by you in the accordance with the rule or not. So obviously right hand thumb rule, first of all let's see the diagram. Okay, here the current is flowing in this direction, so we have to use the right hand thumb rule. That is, if this is the direction of current, then definitely this will be the magnetic field line. So magnetic field lines will point in this direction, and then it will come here and it will point in this direction, right? It is accordance with the right hand thumb rule definitely, and this is the magnetic field lines. Okay, current direction, this is the wire. So this is a very standard diagram. You just need to practice it once or twice. Let's see the right hand thumb rule. If you hold a current carrying conductor in your right hand with your thumb pointing in the direction of the current, the curl of your fingers shows the direction of magnetic field lines. The field lines around a straight conductor carrying current vertically upwards from the concentric circle on the horizontal plane with the direction following the right hand thumb rule. Obviously, right? Now next question number 36, part A. Okay, upper half of a convex lens is covered with a black paper. Okay, upper half of a convex lens is covered with a black paper. Draw a ray diagram to show the formation of the image of an object placed at a distance 2f from such a lens. Mention the position and the nature of the image formed. State the observable difference in the image obtained. If the lens is uncovered, give the reasons to justify your answer. So first let us see what is the diagram. We have a lens, okay, and what they have said that the upper half is covered using a black paper. So upper half is not receiving any light. Upper half is not receiving any light. In fact, you can say that this is not working at all. You can erase this. Only the bottom half is working. Only the bottom half is working. Now you have a light. So this is say F. This is 2F. Okay. You placed an object over here. Now where do you get the image for this case? Will there be any image formation? Yes or no? First of all, so the image will be definitely formed, and in fact it will be forming exactly at 2f. We know that whenever we keep an object at 2f, the image is generally formed at 2f. So here also, even with the half lens, you will get the image, and it will be completely of the same size as the object. So be careful while drawing this ray diagram. Okay, whatever object you have considered, the same size should be of the image. Okay, same size should be of the image. And what will be the difference then? What will be the difference between full lens and half lens? Okay, ray diagram is this, and in this case, how can you, there is no ray, you cannot draw a ray from there, right? So how can you do that? So first of all, you can do that one ray is basically falling on the lens like this through the focus, then it will become parallel after refraction, right? It will become parallel. You have to adjust the distances, don't worry. I am drawing it using my rough hand. So if you adjust the focal length, then definitely you can get that. Other way is, as I said, for 2f we can do the cheating. What cheating we will do? We will just join these 2 points and we will say this is the focus. Okay, this is the cheating we are allowed to do. Okay, especially for 2f case. Secondly, what you can do, you can take another ray from here passing through here, okay, and you can meet it here. Obviously it is not matching because my distances are not very good. I have not taken the distances properly. So this is the 2 rays that you have to consider to draw this ray diagram. Okay, and also you have to remember that the image of this and this will be same as if there is no black paper present. But while drawing the ray diagram, you have to be careful. You cannot pass any ray from the upper half of the lens because no ray is actually passing through the upper half. Now, what will be the difference if you remove the black paper? The black paper, if you remove the black paper, it will only increase the brightness of the image. So image will be slightly brighter and sharper. Other than that, the image, you will still get an image slightly dimmer, okay, maybe slightly blurry. Otherwise, it will be exactly as if there is no black paper present. Okay, so first of all, mention the position and nature. Position is 2f, and nature is real and inverted. Okay, state the observable difference in the image obtained if the lens is uncovered. So if the lens is uncovered, then obviously you will get more light can be focused by the lens, more light can be focused, so you get brighter image. Okay, that is the basic difference between half lens and full lens. Otherwise, half lens will also work as if it is a full lens. Be careful about this. An object is placed at a distance of 30 cm from the optical center of a concave lens of focal length 15 cm. Use the lens formula to determine the distance of the image from the optical center of the lens. Write the nature of the image formed. So concave lens, as I said, concave lens focal length is always negative, and the focal length here is given 15 cm. Okay, the object distance is given 30 cm. Object distance is by default is negative. Okay, we have to find v. So 1 by v minus 1 by u equals to 1 by f. So first we will simplify it without putting the values. That will just reduce some of your trouble. That's it, u plus f divided by uf. So now v is equal to uf divided by u plus f. Now put the values. U is minus 30, f is minus 15, division minus 30 minus 15, that will be minus 45. Minus 30 into minus 15 divided by minus 45. One of the minus sign will be cancelled. Okay, 3 15s are 45, 3 10s are 30, so it will be v is minus 10. Okay, now for a lens, if image and the object are in the same side, then definitely it's a virtual image. So as you can see, it is a virtual image because v is also negative. V is also negative, that means it's a virtual image. It's a, and what will be the magnification? Magnification is v by u, that is minus, even though they have not directly asked you to find the magnification, they have asked you what is the nature. So nature means it will be, if you see v, it is positive. Positive means it's an upright, and less than 1 means it's a diminished image. Okay, so diminished, less than 1 image, diminished, and erect, virtual, diminished, erect. So these are the three properties of the image. Okay, now section 4, section E, 4 marker. When electric current flows in a purely resistive circuit, electrical energy gets fully converted into heat energy. Okay, the amount of heat produced in the circuit is found to be directly proportional to number 1, square of the current. Okay, I square, this is not 12, this will be I square. Okay, the resistance R of the conductor and the time for which the current flows. In other words, H is equal to I square RT. Electrical devices such as electric fuse, electric heater, electric iron, etc. are all based on this effect called heating effect of electric current. So this is the statement. Okay, list 2 properties of heating elements. And number B, list 2 properties of electric fuses. Number C, name the principle on which an electric fuse works. Explain how a fuse wire is capable of saving electrical appliances from getting damaged due to accidentally produced high currents. There is an OR question. Power of an electric heater is 1100 watt. If the potential difference between the two terminals of the heater is 220 volt, find the current flowing in the circuit. What will happen to an electric fuse of rating 5 ampere connected in this circuit? So this is a OR but little long question. Obviously this is also a long question. Let's see the answer. So properties of heating element. So first of all, the statement was already given. So first of it will be a high resistivity, definitely high resistivity. If resistivity is high, resistance will be high, then it can produce higher heat. Ensures sufficient heat generation when the current flows through the element. Now high resistivity, we are saying high resistivity and not high resistance. Why so? Because higher the resistivity, you can create high resistance by using small length. Okay, we know that R is equal to rho L by A, right? So even if if you keep the rho itself higher, which is a property of the material, so if you keep the rho itself higher, for example nichrome wire, okay, nichrome wire has a very high resistivity, that wire can produce high resistance even with a smaller length. Otherwise, if you are using copper wire to produce the same amount of heat, you will need a very huge amount of copper to produce that heat. Okay, that's why high resistivity is important. High melting point prevents the element from melting under the high temperature. So nichrome is another example where nichrome is basically a very high temperature, high melting point wire, so that even if when is heating the water, that is at say at 100 degrees Celsius, water is getting heated at 100 degrees Celsius, but the temperature of the nichrome wire used inside the heater can reach up to quite a few hundred degrees Celsius. Okay, so that is why if it is melting at that temperature, then every time after heating your water for once, you need to replace it again, you have to use a different wire. That is not possible, right? You cannot use a single water heater every day, right? You are not so rich, so every time it is impossible for you to change the coil or in fact the water heater, right? So what they have to keep in mind, that the water heating element of the water heater that keeps working even at higher temperature, that is why it has to have a higher melting point. Now in case of fuse, first property is low melting point. Fuse is basically just opposite to that of the heating element. Okay, fuse should have a very low melting point. It can melt easily under the excessive current to protect the circuit. So if there is a high amount of current is passing through the circuit, because of I square RT, okay, it will produce enough heat, and because of that heat it will melt, so that your circuit is protected. In case sufficient amount of heat is sufficient amount of current is going, the heat generation is not that high, then it will still work. As soon as it exceeds the permissible limit, it will burn. Okay. Now the specific current rating designated designed to allow a specific maximum current, preventing overheating from connected devices. So for example, there are many rated devices that you use in your day-to-day life. For example, microwave, AC, fridge, okay, if you are using OTG ovens, they all have different power ratings. Fan light are okay. Fan light, they generally works on the normal power supplied by our household. Okay, but for all other devices, specific devices, they require specific amount of current to work on. Okay, so if you have seen in your home, okay, a 15 ampere plug is slightly different than that of a 5 ampere plug. Normally all devices work on 5 ampere plug, except those specific devices I mentioned. They might require 15 ampere, some of them might require 30 ampere as well, based on the application. Okay, now if you are using, for example, if your device is 5 ampere rated, but if you are using 15 ampere rated fuse for it, then it will still continue to work if your power rating is power, as long as your current is below 15 ampere. So you should be careful, and the power rating, the current rating of the device should match with the current that is required for the particular device. That is very, very important. Now next is principle for electrical fuse. An electric fuse works on the heating effect of electric current. Explanation: when high current flows through the fuse wire, it generates a heat due to its resistance. If the current exceeds the fuse rated capacity, the heat melts the fuse wire, breaking the circuit. This stops the flow of current, protecting the electric appliances from damage caused by the excessive current. Now this is the OR question. that is a question that I said that is a numerical question. So calculate the current, use the formula power is equal to Y. So V is into I, or I is equal to P by V. It is given 1100 watt, voltage is given 220 volts, so you can get that current is 5 ampere. Now there was another part of the question, what will happen if we use a 5 ampere fuse to this. Okay, since the current is equal to the fuse rating of 5 ampere, the fuse may blow if the current fluctuates slightly or exceeds the limit due to the any surge in the circuit. So basically it will work fine, okay, because it is exactly matching the rating of the device. It should work fine and it will be able to protect the device because both of them has the same current rating. Now if you liked this video, don't forget to give it a thumbs up and subscribe to our channel if you have not yet subscribed. I'll be back with sample paper 10 in our next video. Till then, bye.